As Intel was running out of megahertz possibilities, they turned to another approach to make the Pentium faster. The trick was basically they put two 486s in one chip, side by side. Technically, each one of these 486s is called an instruction pipeline. For reasons I don't quite understand, the first one's called the U, and the second one's called the V. Whether or not the A and the B, or the Herbert and the Melvin, I don't know. But one of those pipelines has a math coprocessor and the other doesn't. So it's almost like having a chip with a 46DX and a 46SX. Here's another term. Multi-pipeline CPUs, and the theory with multi-pipeline CPUs is that we can run multiple things at the same time. The multi-pipeline CPUs are called Supercalar CPUs. The Pentium pulls in a bunch of instructions out of memory and tries to execute them two at a time, keeping both pipelines busy. That's not always possible, so much of the time the second pipeline is idle. But software optimized for a Pentium can go quite quickly. That is, software that's built specifically to keep both pipelines filled. The outside, the external speed of the Pentiums, they call it the bus speed nowadays, is generally either 50, 60, or 66 megahertz, and Intel uses combinations of that to create other speeds. Here's some examples. The 90 megahertz Pentium is really the 60 megahertz Pentium, whose clock is internally increased by 50%. Rather than a clock doubler, it's kind of a clock 1.5-er. The 133 is just a 66 doubled. The 120 is just a 60 doubled. The 75 is a 50, 1.5, and so on. The thing to understand here is that no Intel chip actually runs externally at faster than 66 megahertz.